Alright, let us get started with our question. So we will be solving Leetcode 905 problem called as sort array by parity. So let us look at the problem description. We are given an integer array called nums and we are expected to move all even integers at the beginning of the array followed by all odd integers. So what does this mean? So let us take an example. Let's say that our input array is 3, 1, 2 and 4. Then our output can be we have to move all even numbers first and then all the odd numbers. So this is a valid output. Output can also be like this 4, 2, 3 and 1. It still has all the even numbers in the beginning of the array and odd numbers at the end of the array. Right. Now, how to solve this problem? How can we really achieve this particular solution? So let us go to the notes and see how we can do it. So here I've taken example as 1, 2, 3, 4, 5 combination of even and odd numbers, and output is 2, 4 which are even numbers and 1, 3, 5 are odd numbers. So one way to do it is let's say you have an input 1, 2, 3, 4 and 5 and you have a result array. What you can do is you can run through the loop, run through this array and get all the even numbers first and then run it again and get all the odd numbers. This is how you can solve this problem. Okay, so let me write the code. Right, so it will be like this. Public int array sort by parity and our input array is here. Let me make sure this is done properly. Okay, now let us define our result array, and the size of the result array will be same as the input size. Okay, and let us say k is equal to 0. This will be result array index. Okay, now we have to copy all the even numbers first to result array because they need to be shifted on the beginning of the array, which is left hand side of the array, and then all the odd numbers. So let us write code for that. So let's say for int I is equal to 0, I is less than array dot length I plus plus if array of I mod 2 is equal to 0, result of k plus plus is equal to arr of I. Okay, this is how we can move all the even numbers. Now let us take a look at how to move all the odd numbers. So for int I equal to 0, I is less than array dot length I plus plus if array of I mod 2 is not equal to 0, which means it is an odd number, result of k plus plus is equal to array of I. Okay, we are done. Now just return the result. That's it. Done. Our code is done here. Now let us take a look at time and space complexity that will happen for this particular algorithm. So what we did was over here we created an auxiliary array, which means that uh, the space complexity will be of n because we created the result array with size array dot length, right? So for any input size n, we are creating a result array, right? How much will be the time complexity? So for time complexity, we are iterating through entire array one time over here and another time over here. Okay, so this constitutes to of 2n and this can be brought to O of n because we usually don't consider the constants, that it doesn't have much value in time complexity. So this is your time complexity, and this will be the space complexity. Both will be O of n. So let us go to Leetcode and input this code and see whether this works or not.
Right. So let us write the code that we already wrote in the notes. Okay, so first let us create our auxiliary array called result with same size as input, and we will be returning that result. Okay, and we will also create an index which will be um, used to track the data that we inserted into our result. And now let us just add all the even numbers into our result. So nums dot length, iterate through the array, right? If nums of I mod 2 is equal to 0, result of k plus plus is equal to nums of I. That's it. This was for odd numbers, and this will be for, sorry, that was for even numbers. Okay, copy even numbers. Okay, and over here you copy odd numbers. Okay, that's it. Let us just submit this code and see whether this worked or not. And it worked, but there is one another problem with this, and the problem is that this auxiliary array, right? Let's say nums length is like 1 million. Okay, and we will end up creating this result array with size 1 million, right? So that's not a good solution, right? Maybe we can do something better, right? One way to solve this problem is to just shift the numbers using two different pointers. So let us go back to the notes and I will show you how to do that.
So let us take a look at two pointer solution approach. The two pointer solution approach dictates that we have two different pointers assigned some value. Let's say I is equal to 0 and j is equal to n minus 1. Alright, so how did we assign these values? How did we come to the point where we say I is equal to 0 and j is equal to n minus 1? So let me write the input over here: 1, 2, 3, 4, and 5. Okay, now let's do this. Let's say our idea over here is to move all the even elements towards the left hand side of the array and odd elements to the right hand side of the array. So I index will be used to work with even, and odd elements, for odd elements we'll use j. Okay, so I will be pointing over here, whereas j will be pointing over here. Okay, what we intend to do over here is, let us think about a use case where our input element is like this: 2, 4, 6, and 8. If all of them are even numbers, we can just increment I to the point where I is equal to length of the I is equal to array dot length, and we don't have to do anything. Okay, let's say input is 1, 3, 5, 7. This means that if j is over here, we'll keep on decrementing j, and j will become one time become minus 1, which means we don't need any swapping or anything. All the elements are in place over here, all the elements are in place over here. If the element are not in the correct place, then it is our responsibility to go ahead and put the elements in place. So how will that work? Okay, so let us take a look at this solution. Okay, over here I put I equal to 0 and j is equal to 4, which is index for element 5. So I is equal to 0, it is even number? No, it is not. So I will stay here as it is, it will stay put. Let's go to j. J is equal to 4. Is j of 4 is odd number? Yes. Decrement j. J comes over here. Okay. So in second iteration, I is equal to 0 and j is equal to 3. Now this is odd value, this is even value. So what we will do is over here we know that these both values do not match, which means that 4 needs to be shifted over here and 1 needs to be shifted over here. Let us say we make that kind of swap. So we get 4, 2, 3, 1 and 5. We come over here. This is good. Okay. Now let's go back again. So I is equal to 0, j is equal to 3. So these both elements are at the right place. Again, increment the I over here, decrement the j. Again, increment the I over here and decrement the j. So now see what really happened over here is I is equal to 2 and j is equal to 1. So okay, when, sorry, let me erase this. When I is less than j, do something, else things are already taken care of. This I and j's, this will only happen when all the elements are at the right place, else this will never happen, right? This is the example that proves that. Okay, now let us write the code for this one and see why this will work. The idea over here is that let us, whatever even numbers we get on the left hand side of the array, just run through all of them and don't do anything. Whatever odd numbers we get from the right hand side of the array from here, all right, at that time only you run through all the odd elements. If something happens and you cannot run through those elements, and if I is less than j, then you have to go ahead and swap, else you don't need to do anything. Let us take a look at the code. Okay, so this is our method signature, sort by parity, and let us create our uh, start and end pointers. So let's say the start pointer is named as I and end pointer is named as j, which will point to the last element. Okay, this should be -1. Let me make sure it's minus. Okay, now let's say that these pointers are at the right place and have not crossed each other. If they crossed each other, then we got our solution. Okay, so now let us run through all the even numbers. How to do that? Let's say I is less than array dot length. Always making this mistake. Array dot length and array of I mod 2 equal to 0, then I plus plus. Okay, run through all the even numbers, and while j is greater than or equal to 0 and array of j mod 2 not equal to 0, j minus minus. And if I is less than j, then you call a swap method, which will take array both the index and it will swap the values and return. Okay, if this is while, you return the array and close it out. Okay, so there are two things to note over here. First is this one, this condition, and second is this condition. Why did we wrote these two conditions? Okay, so let me explain. The first condition, I less than this one, this condition. Why is this condition needed? It can, array input can be like this, right? Array input can be like 2, 4, 6 and 8, all the even numbers. You won't find any odd numbers. So you have to make sure that your I bound does not go outside the array. If it does, then you get array out of bounds array, right? Same thing is for the second condition. Okay, what if you are given input as 1, 3, 5 and 7? Your j will start from here, it will move all the way here. It should not be the case that it comes over here and j becomes -1, then you get array out of bounds error. So these are the two conditions that you need to be aware of, and that's it. This is the solution. Okay, Now let us go ahead and implement this in Leetcode and see whether this will really work or not.
Let me erase this solution for now. Okay, and we'll implement our better solution. Okay, and let's start with it. Int I equal to 0. This is the start pointer, this is the end pointer. Okay, points to the first element, this points to the last element. Okay, so now let's say while I is less than j, and while I is less than nums dot length, and nums of I mod 2 is equal to 0, then run through the even counter I plus plus. Okay, same thing you need to do with j. Let me not copy it, else I will make mistake. J is greater than or equal to 0, and nums of j mod 2 is not equal to 0, j minus minus. Okay, and if I is less than j, you can call swap method, which will take array I and j, which will swap the values. Let us assume it is going to swap it. And lastly, just return the input array that you got. So we have modified it in place, so the time complexity is of n, space complexity will be of 1. Okay, void swap. Okay, so this should be nums int I and j. So let's say int temp equal to nums of I, nums of I equal to nums of j, and nums of j equal to temp. Okay, submit. Let's see if this works. Right, so this worked. So this is the solution, good solution, right, where we are not using any extra space, but we are using the same amount of space, optimal amount of space, right? We are not using anything extra, just two variables. Now let me come to the last solution that I was talking about stream API, how to do that. In order to use the stream API, what we have to think about is we can sort this array. Okay, if you think about an array, think about these values. How you can sort the array that all the element move to left, even element move to left, and odd element move to right. Well, let's say that you have a custom comparator. Okay, and the comparator will compare based on the strategy whether the numbers are even or odd. So let me tell you how you can write that comparator. Let's say comparator of integer is equal to, let's say this is first value and second value, and you can say integer dot compare a mod 2 and b mod 2. Okay, as simple as that. Now why will this work? Okay, let me remove everything from here. So the question is, why will this thing work? Okay, a mod 2 means it's even, b mod 2 means it's even or odd. That is the decision that it is going to take. If this a mod 2 is 0, it means that this number is smaller and will be moved to the left hand side of the array. B mod 2, if it is odd, then it will move towards the right side of the array, and converse is also true, which means that B mod 2 is even, then it will move to the left hand side of the array. If A mod 2 is odd, then it will move towards the right hand side of the array. So how can we write this code? Okay, so we can write something like this. Okay, nums, like, let's say return, okay, arrays dot arrays dot stream numbers. Okay, and we convert it into integer element. Okay, integer means into integer. sort them using this same strategy like this. Okay, sorted dot map to int, convert integer to int using int value method, and just say to array. Okay, let me remove this. Let's see if this worked. Okay, syntax error. Okay, this worked. So this code will not be faster because first of all we are doing comparison, and worst case scenario for this thing is and log and time complexity, and this to array method is going to make sure that you copy all the elements into the new array and return it, right? So this gives you space complexity of n. So for this problem, if we use streams, then streams and sorted, then time complexity is of n log n, and space complexity will be of n, as to array method is going to create a new array, add all the elements into it and return it. So it's going to, for space it is bad, but for time it is much more bad because it is doing sorting. Where in previous solution we didn't need any sorting, we were just copying the elements and swapping it. That's it. So that's about it for this video. Thanks.